Okay, so looking at these two, you've got one of each type. So we have one where the absolute value is going to be less than and one where it's going to be greater than. And then they also throw in the equals to sign here. But the rule basically, we have two different rules for when we're dealing with the less than and then when we're dealing with greater than. So if we just follow the rule, it's pretty simple, but sometimes, following the rule, we kind of want a little bit more in depth to kind of understand what's taking place. But let's look at the less than part right here. So remember, absolute value will turn values positive even if they're negative, right? It's the distance from zero. So what this is saying is do not wander off from, let's put zero right here in this example, do not wander off in either direction, the positive or negative direction of whatever A is. So in this case, it's going to be 3 units. So this expression can't be more than 3 or less than -3. So that's exactly what we're going to write down here. So we're going to take 8x plus 2, and it needs to be less than 3, but then greater than -3 so that we don't wander off past our boundaries right here, right? And that's part of the rule right here. So if you just follow the rule, you can't really go wrong. But like I said, I understand sometimes we want a little bit more of an explanation. So hopefully that kind of helps a little bit. From here, once you get to this point, just don't overthink it. Solve this. So we have our compound inequality. So we'll subtract by 2 everywhere to get started. And then let's see. So we'll have -5 is less than 8x, which is then less than 1. And then we'll go ahead and divide everything by 8. And that'll be our solution for the first one. So it can get kind of messy if we've got a lot of stuff going on inside of the absolute value. And so that's going to be our solution, everything that's greater than -5/8 but less than +1/8. And so since we don't have the equals to sign underneath it, we have to use our parentheses. So -5/8 and +1/8 on this side with parentheses on both sides. Okay, then let's look at part 2. That's going to be where we have the greater than. So now what we're saying is wherever zero's at, we'll put it right here. We're saying, you know what, you need to keep your distance, stay away from 0, right? Because absolute value is distance from 0. So we're saying your distance needs to be at least 2 units away from 0. So once again, you can just follow the rules here. And so it's a little different than the previous one. We had a compound where we could write it all as 1, but we're going to write this as 6x minus 2 needs to be greater than or equal to 2, or now what you're going to do is you're going to flip that and change the sign, or 6x minus 2 needs to be less than or equal to -2. And so that second one's this part of it saying, hey, you need to keep your distance from me, stay at least 2 units away. And so in this case, it's -2. So stay away 2 units. So once again, don't overthink it. Once you get to this point, solve these, and you'll have your solution set. So let's see, we'll start by adding 2 here. 6x is greater than or equal to 4. And then when we divide by 6 here, we do want to reduce. Always reduce when you can. So we can reduce this down to 2/3. And then on the other one, same thing. So let's see, we'll add 2. And so let's see, we're going to get 6x equals 0. Interesting, okay. Then we'll divide by 6. And so we're going to get x, not equals, sorry. Or I could see, there we go. Less than or equal to 0. There we go. Okay, so you got to kind of be a little careful on this one, especially when you have the 2 inequalities separate right here. So we have 2 possibilities. X can either be greater than or equal to 2/3, or it's going to have to be less than or equal to 0. And so you don't have to do a number line. They're not asking you to, but sometimes that can be a little helpful in visualizing what's going on. So you kind of want to list this stuff in numerical order. So 0 would be about right here, and then 2/3, we'll put it right here. So it doesn't have to be to scale, but you want it to be accurate as far as putting your numbers in the right order. So the first one's saying x needs to be greater than or equal to 2/3. So greater than is going to be to the right. Values are greater to the right towards positive infinity. or we can pick values that are less than or equal to 0. So less than is left. Remember, less left. So like that, going towards negative infinity. So now it's time to convert this into our interval notation. So we're going to go from negative infinity to 0, and then we'll bracket that in. And we have to use our union right there to add in our other interval right here. So then our other interval is from 2/3 to infinity, and there we go. All right, so hopefully that helps you out. If you need anything else, just let me know.